Okay, we can get started. There's one student in the class personally, which is kind of weird. Usually I like to ask questions, so I might pick up Timur. Is that right? Yeah, okay. And then if you guys can chime in on Discord, that would be great. This lecture shouldn't be too long. Um, but just to follow up, so you should have handed in your first assignment. It's only worth 5%, but really you have to get Git working and you have to get that log. And I know it's an error log. If you did it some other way with Express or whatever, I don't really care. You'll get the full marks. It's more that I need Git to connect to Vercel. That's like the main key of that assignment. Because for assignment 2, 3, 4, 5, we're going to use Express and all of this stuff. And contact me if you didn't get it working, because it's super important for assignment 2, 3, 4, 5, 6, basically all the way to the end. I released the test or lab, if you want to call it, that is out today. And you have probably a little more than 24 hours, 30 hours to finish it. So tomorrow at 11:59 p.m., it is due. And if you want to take a quick look at it, it's not crazy difficult, but it's based on the first 2 weeks of material. So if just open up test and lab, it's test number 1. Oh shit, did I not put? Yeah, here it is. Cool. So it's like, 20 questions. That's actually 16 questions, and just fill it out in one file. And yeah, it shouldn't be that difficult to do. Let me know if you have any questions by the end of the day, but make sure you get it in before that 11:59. Otherwise, it's automatically 0, and it's worth 10%. So it's probably like one of the easiest labs or tests to get that 10% on. Any questions, comments? You're good? Yeah, nice. Okay. This is weird. I've never done a class with one person in person before. That's fun. It's fun. We can make fun of everyone else online and they can't hear us. Okay, wait. Someone's typing in Discord. We'll just see what they say. Oh, yeah. Also, if you're chatting, try to do it in the Discord instead of the Zoom chat, just so we have a record of it. But yeah, if you used Express for assignment 1, it's totally fine. We just don't cover Express till next week. So let's talk about this. We're going to go over this asynchronous code, and it's like the last JavaScript kind of review that we're going to do. And then we get into the fun stuff. We're going to learn what that node modules directory or folder is for. We're going to program our own web server, which is really interesting. I'm going to show you kind of how that works, but that's going to be next week. So again, this is the last kind of, I wouldn't say review. I think we covered a lot of it in Web 2.2.2, but I promise the course gets way, way, way more interesting. Okay, so let's see. This week, asynchronous. So JavaScript, like, it's a weird language, right? And I've shown it before. You can do one thing 10 different ways all the time. And we can also do these things called threads or asynchronous calls. Now, JavaScript is an asynchronous language that allows us to do synchronous things. Now, the question that I usually pose is, what is asynchronous and what is synchronous? Do you know? Okay, what is it?
Order asynchronous when it's go like different thread, if I can say that, like it's resolving in the same time as the other threads issues.
Yeah, that's great. If you couldn't hear, he said synchronous is in order, and then asynchronous is like, well, we'll say out of order or in a controlled order. So if you remember last class, I had some code like this that said hello world, and I put the world in a timer that would run after 2 seconds, and then whatever, I had an exclamation mark. And if we run this code, you'll see that it says hello and then exclamation mark and then world, right? So like a simple way, or a way that I kind of remember this, is if you go to Starbucks or Tim Hortons and you order a coffee and you're sitting there and you're just staring at the person making your coffee and you can't do anything else. All you're doing is waiting for that coffee. And then the person gives you the coffee and you go away. That's synchronous. Asynchronous would be you order the coffee, you give them your name, you go away, you go read a book, you go work on your laptop, whatever, and they call your name, and then your coffee's ready and you go back and get it. So you can do multiple things at the same time. So JavaScript, again, it's like an asynchronous language that can do synchronous things, which is kind of weird. But we typically use this so that we don't make the user wait. Like it's weird if someone is just standing at you, staring at you, making coffee, right? Like that's strange. So instead, but a better tech example of this is, say, connecting to a database. So if we connect to a database, or sorry, if we want to get retrieve data from a database, we need to connect to it first, make sure that we're authenticated, and then get the data. If you try to get the data first, it's not going to work because we don't have a connection to the database. So I kind of run in with an example that looks like this. And it looks a little confusing, so bear with me. And I'll go through it, but I have two functions here. And if I get rid of these timers for the time being, they're pretty simple functions. One's connect to database and one's query data. And they're just two console.logs, right? Pretty simple. I've added two timers, set timeout. And it looks like a lot of code or weird, but basically this is saying, give me a time between 0 and 2 seconds. And just run this connection established after that time. I don't know what the random time is. No one does. And this one works in 1 second. And it does the same exact thing. It says query completed. So if I run these two functions, really doesn't matter what order I run them in, but sometimes we'll get query complete first, and the next time we'll get connection established, right? We don't know because we don't know how long it's going to take. And this is like a simple real world example because I don't know how long it's going to take to connect to that cloud server in Las Vegas or wherever, right? It might take some time. So not me, but someone had to invent a way so that we could determine when something finished. And JavaScript, again, is a cool kind of scripting language because not only can we pass data to functions like we usually do, like say, for example, we have function add num1, num2, and then console.log, num1 plus num2. Not only can I do this, or actually just do this, right, which will give us 14. I can also pass functions to other functions, which is weird, right? Like it's not C++ really doesn't let you do it. It kind of does. But we can actually take, instead of passing variables, we can pass the actual function to itself. So what we can do, and again, we'll make this example real simple, is I can say, I'd like to connect to the database, and then I'd like to run our query data function. So just, again, get rid of the timers for convenience sake. So I'd connect to database and then run query data like this. But inside of connect to database, I have to say, I will take the parameter query data and then run it. Right? So you got to think of this as now, I'm not just passing a variable, some number that I'm going to add. I'm actually going to pass this entire chunk of code over to this function, and then I'm going to run it. So we can see this, right? So now in this scenario, the connect to the database fires, and then we run this data. A better example with the timer, if I show you, looks like this. And inside of connect to database, again, we'll just put query data. And then in here, we'll run it. So now we can guarantee that we're going to connect first, then get the query from the database. So those are called callbacks. And this was the initial way that we stopped and waited for data effectively. I'll show you some other intricacies with that, like passing parameters. But we moved on because people were doing this so often. And think about when you would use this, right? Like, so when you make a website like Facebook, Instagram, and you scroll through Instagram and you get that little spinner, right? You might actually connect to the database instead of query data. Right before this, you might say like, display loading screen. Then connect to DB. And then inside of here, once we query the data, you might want to remove loading screen, right? So this is when we know that we have the connection, we can grab the data. This was happening so much on so many websites. Programmers added syntax sugar. And it's not that it's difficult, it's just, it becomes difficult to watch all of these different threads, right? So for example, let's do a real easy scenario. I can have 3 outputs. So these are 3 functions, they're identical. One outputs A, one outputs B, one outputs C. And if I use callbacks, the code becomes a little bit complicated because it turns into this. Right? So I have output A, it takes the first callback and the second one. Output B takes the last one. Output C takes nothing. Then I have to pass in A, B, and C, which this can get super confusing, but it allows us to run A, B, and C all the time. So instead of this, these things were invented called promises. So it's like when you call your friend and they're like, no, I'm busy right now. I promise to call you back. That's where this name like callback and promise comes from. So that looks like this. So we'll just get rid of the other functions and just show you a simple one. And I'll get rid of the timer again, just to show you how it looks. And this is the code. So if I run this code, what's happening inside of the function is instead of say doing console.log or returning just like, hello world or whatever it is, this is instantiating a new object called promise that came out in like 2016. And this promise has, well, it has more than 2, but in this case, it has 2 functions built in. One's called resolve, one's called reject. So this resolve actually effectively sends back true. So if this function is successful, it sends back a true to whatever other function that is calling it. And if it's not working, it does something called a reject. So let's just see what happens when we call this just regularly. And notice it just says A, but I haven't really done anything. Like I don't know in this scenario when this promise is saying true. So they added a feature called then. So this is like almost like an if statement. It's saying run this function A, then when it's completed, do anything that's inside of these brackets. So I can actually put another function inside of this bracket. Like this. And we use arrow function. Oops. That should be it. Oh, it's brackets. I always miss some stupid thing. There we go. So it's almost like an if statement, right? Like output A, then run this. So in this scenario, it's outputting A, which is this console.log. Then it runs the resolve, which triggers this then. And then it shows you output A is complete. So now this is like a callback, but we don't have to send in the next function that we want to run. So it's kind of cool, I think, anyway. So that saves us a bunch of time and a bunch of callbacks. Let's see what else. We can do reject. Let's pass data. So let's say, for example, maybe this was an API call. And in here, we get the data back from the API, right? So this would be the API call. We get the data. And now I want to send this data back to this function because I'm going to, inside of this function, I might populate the web page. So in this resolve, we can actually pass data back like hello world. And inside of our then, we just do something like this. And if this all works, this should be fine. And we should get hello world, but back here in the output, which we do. Right? So this hello world doesn't have to be hello world. It could be var some data equals hello world. It could be an object, whatever you want it to be. But this is how, again, we get some data and we can kind of wait for it to happen. So callbacks, promises, super important. Reject works the exact same way, except for a reject will throw an error. So notice reject. And I would have to put this in a try and catch to actually catch the error. I'm not going to do that right now. Make sense? Yeah. But let's go back to our other example when I had 3 of these, right? So I have output A, output B, output C. I set up the promises. I don't know what times they're going to run between 0 and 3 seconds. And then I'm going to have to type out output A dot then, output B, so on and so forth. So it ends up looking like this. Right. And you can see there, I'm going to run output A. When that's finished, I'm going to send the data to the console. Then I'm going to run output B. Then after I run output B, I'm going to run output C. Then I'm going to put all of the output from C into the console. And if there's an error, I'm going to catch that. Output C intentionally, I put an error, so you'll see it happen. But watch this. It might be random. What did I do? Hold on. There we go. Yeah, so it's a random error. This might actually complete. There you go. A, B, and error. Right. So this says, actually, in fact, I'll just tell you how it works. Notice if random time is mod 2, then it will give you a resolve. If not, it'll reject there. It's just a sample to show you how it kind of works. But again, in this scenario, we can now, make sure output A runs and then make sure output B runs and make output C runs. So callbacks turned into promises. And if you remember from last class, we call it syntax sugar, right? Because it does the exact same thing, but it's an easier syntax effectively to do it. Question? No? Yes.
When we do the DOM manipulation with having callbacks, it's the promise or just the way
Yeah, it's not technically it's not a promise because it's using like the older version of JavaScript to do the callback. So you're actually passing the entire function. The promise is doing the same thing, but in the background. So we don't have to actually physically pass it. It's just like an easier way to do it. And then this got, I wouldn't say sloppy. It's just like, it is sloppy. I don't know. It's a lot of code. Output, then output, then. So I think it was 2000 and the dates don't matter, but 16 or 17, JavaScript came out with something called await. And you may have seen this in C++ or C# or Java. And in those languages, you can do this thing called threading. So if you've ever heard of like a processor with multi-threaded processor with multiple processors, it means you can run more than one thing at the same time, which like all computers do now. And sometimes you either want that or don't want that, but we can also make the processor kind of wait for this to happen. In JavaScript, that used to be tough. We used to actually have to do all these callbacks, but they added this syntax sugar to allow us to do async functions, and it looks like this. Now we still have to do our promises, but now we don't have to do the dot then. So in this scenario, everything else is the same, but I say, let's await for output A to finish. And this will just actually wait here. It's not going to go to this console.log A until this is done. And the same for B and same for C. So this got much easier. The only caveat is with this is that we have to put this in a function and actually specify that it's an asynchronous function, because this actually does not work because the main in JavaScript is not async, it's just synchronous. So we have to determine, or we have to tell that JavaScript is asynchronous. So if I run this, it'll randomly give me whatever it is. Oh, I got to run show output. And same as before. So why do we care? Obviously, like I said, getting data from, say, a different server and making it look good for the user is the key for this. So if I go to a website like CNN, if this website waited for everything to load one at a time, we'd see a white blank page, and then we'd see the first picture, and then we'd see the second picture, and then we'd see this the third, so on and so forth. But with this sort of JavaScript and threading and asynchronous calls, this loads all at the same time. A better example, which I can't really show you, I don't want to log into my Instagram here, but if you go to Instagram and you scroll through Instagram really quickly, you can see that these are async calls because a spinner might pop up, right? And then it has to wait for that to load, and then it reloads the entire page. So this is how React, Angular, Vue, JS, they all work like this. And they all work with promises. And you can decide if you want to use await or the dot then. And both are widely accepted. Callbacks, less used. You probably don't see them too often. Any questions, comments? Does that make sense though? Yeah. Anyone online? Let's see. Can we await an async function so we can await show output? Well, good question. I'm not sure, but let's try it. Await show output. I'm not, that would mean that this, if we awaited this show output, it means none of this would show until it ended. Yeah, I don't think that would work. Yeah. Yeah, because you can only await functions that are inside an async function. And remember, I finished saying before, the main JavaScript thread is not async, it's synchronous. That was a Discord question. So you're going to use this, but not immediately. You're going to use it probably. What's that? Yeah, well, definitely down there, right here. But I think we do a little bit in UI toolkits because in assignment, yeah, I guess you're right. It probably is down here in Web API because in assignment 3, we take a file, a JSON file, and we import it into our website. So we use an await function because we want to read the file into memory first and then output it. Right? Our computers are so quick now that sometimes, or you can write this code without these asyncs and awaits, but we get something called a race condition. And a race condition means you're not controlling when things are finishing. So each function is racing to finish first. So a scenario that can happen, I'll show you real quick. Hopefully, let's see if I can find one. Let's see. I know I had one last class. Right here. So let's take this, for example, I'll send this in Discord, but we have a counter that's global, but we have async functions that are incrementing or decrementing the counter at their own will. So when I run this code, each task might be getting sent back a different counter result that it wasn't expecting. Now this one, I got to refresh it a couple times, but there's one, right? So the task 1 sets counter to 0 or to 1. And then, I don't know, let's see if we can get another one. There you go. Shared counter to 1. But see, notice that it moves in different orders. So we don't know when it's going to happen. These are race conditions. It's a real problem in something like if you're programming network interfaces, because you're sending data down a network cable and you can't necessarily tell if the other computer is receiving the data or not. So race conditions in routers and Wi-Fi routers is really a problem, which they've like people smarter than me has solved. But you know, I'll paste this into Discord so you can kind of play around with it. They also call them blocking conditions, I think, as well, because your function could run forever waiting for another function to finish, but that function could have finished before the other one got started. So it infinitely be waiting. It's called a blocking condition. Not super relevant in JavaScript, more in C and C++, but. Any questions? Any questions? No.
What's wrong is that all like
What is this?
on the bottom there's problems that all.
Dot all? Okay, so all will fire all promises effectively. So like this will say, I'm gonna run increment counter and double counter, and whatever one comes back will fire allow you to move on. So it's like a catch all, but that's why it fires a race condition. I don't know which one will come back. I'm not sure the scenario you would use all in real life, but there obviously is one. I've never used it. Well, that was like the fastest lecture I've ever done. Mostly because you guys didn't show up, except for you. Bonus marks for you. So that's it. That's it. It is a short lecture. So really what I would do if I were you, I would actually do or start the test, those 16 questions, because you have an hour, at least an hour left to work on it. And it should, I would guess, only take you an hour if you really, yeah, I don't think it would take you much longer than an hour to do this. Don't use ChatGPT. You're not like, it could easily do this for you. And there's nothing stopping me from doing that, but you're not going to learn how these things work. The point of this is go back to week 1, go back to week 2, find out how to write object literal notation, write one for car, right? Like you could do it easily in ChatGPT. Don't do it. You're not helping yourself learn this stuff, and you're gonna have to know how to do this later for the assignment. So, if you get stuck, again, don't ask ChatGPT, just ask me. I'll walk you through it however you need. But that's it. So I'm here to help you for next whatever it is until this class is over. Otherwise, it's due tomorrow midnight. And that's it for today. If there's no questions, I'm gonna stop the screen share, but I'm still in Discord if you need. Have a great day.